Hi all. Today we discuss section 22.6 interpolation and extrapolation. The definition of interpolation is given here. Before that, I give you the insight of the definition of the interpolation. Suppose we have a function f and with the domain A and codomain B, and suppose we have values, say some 1, 2, 8, 9. 20, we have this much values for the domain, and we know that what are the values of f of x at these points. Okay, so at the, if we have x's are 1, 2, 8, 9, 20, then we have the value of f of x at these points are given to be say some 5, 10, 81, 22, 4. Suppose these are the given values, or you are given a finite number of n tuples x comma f of x. Okay, so these are the scenario here, and using the values of x and f of x, this much values of x and f of x, how can you find the value of f at 2.5? That means we need to find out a value of the function f at the point 2.5. This is inside the interval 1, 20. So these are the values of x given. Okay. So if we choose any value in between this 1 and 20 and try to find out the function value at that point. So the process of finding this f value at 2.5 is called the interpolation. Okay. Now, in the similar fashion, you can find out the value of this f at some other point 30.3. So for the purpose of finding the value of f at 30.3, that is outside this interval, that process is called extrapolation. Okay, that means using these values, we can extrapolate the value of f outside this interval. Similarly, you can interpolate the value of f inside this interval. Okay, so this is the definition of extrapolation and interpolation. If the values of f of x are known for x equal to x0, x1, x2, xn, then the process of finding the value of f of x for any other value in the interval from x0 to xn, open interval x0 to xn, is called interpolation. And the process of finding the values of f of x for a value of x outside the interval is called extrapolation. So this is the definition of extrapolation and interpolation. So we discuss how can we interpolate the value of f if the given values of x are in a nice manner, or if these the values of x is in equidistant. That means if the uniform interval, say 1, 2, 3, 4, 5, in this manner, or if we have x0 and x1 is obtained by adding h to this x0, and x2 is obtained by adding h, the same difference to this x1, and so on. If the intervals, the points are uniform, or if there is a common difference between any two consecutive points, then we can say that the uniform the values of f are given in uniform intervals. In that case, first we will discuss how to find, interpolate, and extrapolate the value of f if these values of x or arguments are given in a AP, or that's in a nice manner. Okay. Later we will discuss the interpolation and extrapolation for unequal intervals. Okay. So this is the equal intervals. So these are the one example for unequal intervals. Okay, 1, 2, 8, 9, 20 are unequal intervals. But if these are the values of x, then we can say that these are the equal intervals. First, we will discuss the interpolation and extrapolation for equal intervals. First, we define Newton-Gregory formula for equal intervals. In this section, we discuss Newton-Gregory forward difference interpolation formula. Intervals are equal. That means we have Newton-Gregory forward interpolation formula, known as forward interpolation formula. Interpolation formula. This is forward formula. So this is obtained from the definition of E. Okay, so if we have f of a plus n h, in order to evaluate f of a plus n h, this is we connect this with our shift operator, that is E n of f of a. Okay, so this is equal to 1 plus delta. We have already proved that 1 plus delta is equal to E, then 1 plus delta times n raised to n f of a, and we expand 1 plus delta raised to n using binomial expansion. If this n is not an integer, if this for any real number n, you can expand this 1 plus delta, that is 1 plus delta raised to n, that is going to be 1 plus n times delta plus n times n minus 1 times divided by 2 factorial and times this times delta square plus n into n minus 1 n minus 2 divided by factorial 3 times delta cube, etc. This is the expansion of 1 plus delta whole raised to n, even though this n is not an integer, of this f. Okay. Now you apply this f of a to apply this operator to this f of a. The first time will be f of a itself, and second time will be n times delta of f of a, that is n times delta f of a plus n into n minus 1 by factorial 2 times delta square f of a plus so on. Okay, so and we denote this f of a plus n h in terms of delta, that is this is f of a plus, and usually we denote f of a as y naught, so we replace it by y naught. Instead of writing f of a, we write it as a naught, sorry, y naught. This is y naught plus n times delta y naught plus n into n minus 1 by 2 factorial times delta square y naught plus etc. The third term will be n times n minus 1 times n minus 2 divided by 3 factorial times delta cube y naught plus etc. So this is what we call Newton-Gregory forward interpolation formula. So in order to find out f of a plus nh, we write we will find y naught, delta y naught, delta square y naught, so on, and evaluate this. Okay. So we take the number of terms of the right hand side of the series of this equation by the requirement of with the requirement of the places significant digits, significant figures. So if you have we will later decide how many terms are to be taken to evaluate this f of a plus nh approximately. So in the similar fashion, you can define Newton-Gregory backward interpolation formula. That is, the only difference is E can be replaced by the corresponding equation for replaced by the relation connecting E and del. So that will give, that is known as Newton-Gregory backward interpolation. Backward interpolation formula, that is nothing but f of a minus nh, that is equal to e to the power minus n f of a, that is equal to e minus 1 whole raised to n f of a. We know that e raised to minus 1 is equal to 1 minus del, so that can be replaced by 1 minus del raised to n, and we got this as f of a. By expanding the previous pattern, you write f of a minus n times del f of a. I'm not going to write all this repeatedly. So n times del f of a, n minus 1 by factorial to del square f of a minus, here we have the only difference is the sign of these series. First we have minus here, uh, as here 1 minus delta raised to n, and n into n minus 1 into n minus 2 divided by factorial 3 times del cube f of a and so on, plus etc. So we write in terms of y0, y1, y2, we write this same as f of a minus n h is same as y0, f of a can be replaced by y0 minus n times del yn plus n times n minus 1 by 2 factorial times del square, this is y0, it's not yn, this is y0, del square y0, and so on. So this is what we call the backward interpolation formula. So in the next class we will discuss the problems involving this forward difference formula and backward difference interpolation formulas.